So consider this problem statement. So it says that x is between 0 and pi radian, and cosine of x plus sine of x is equal to half. So in that case, we need to compute this absolute value of 27 times tangent of x over negative of 4 plus square root of 7. So let's proceed towards the solution. Now first of all, I'll consider this given equation, and then with regard to this we'll proceed ahead. So first of all, I'll be squaring both the sides so that I can apply some identities after expansion of this expression, right, involved in the equation. Now here I'll be applying the identity, that is a plus b whole squared. So this can be written as cos x square plus sin x square and then 2ab, that is plus 2 times cosine of x times sine of x, and this will be equal to 1/4. Now once this part is done, so we know this identity that cosine square x plus sine square x, this is equal to 1, and 2 times of cosine x times sine x, so this can be written as sine of 2x. And then after this, if I isolate this sine of 2x over here, so from this one, on subtracting 1 on both the sides, I'll be getting this one as 3/4, and this would be negative, right? Now in the expression here we have tan x, so we need to apply some strategy by which we can relate this sin to x and tan, right? So in this case I'll try to reverse engineer, I'll try to apply some kind of approach here by which I can convert this sin x to some expression that involves tan x, right? So let's just think about it. So here we are given sin 2x, right? Now think about it. How can we arrive with the expression which contains tan and it is equivalent to sin 2x, right? So what we can do here, I'll be taking this sin x, sin 2x, and then try to proceed accordingly. So what I will do here in this one, so sin 2x can be written as 2 times uh, yes, 2 times sin x times cos x, right? So 2 cos x times sin x. Now here I'll multiply cos square x in the denominator as well as in the numerator. So this will become cos square x and this will be cos x, right? Now on proceeding further, so I'll just take it on this side. Yes. Now from this one, so here I'll isolate this 2 times sin x over cos x, and with the other one where I'm having this cosine square x, and in the denominator we are already having 1. So instead of this one, I'll be writing cos x square plus sin x square, right? Now from this one we can write, so in the numerator I can write this 2 times sin x over cos x, and in the denominator this one can be written as 1 plus sin x over cos x squared, sin x over cos x squared, right? So if you observe here, this will be cos square x plus sin square x, and this in the denominator would be cos square x. So this one I have just converted into this particular expression, and this part was already there in the numerator. Now we can clearly observe that we are having tan x in front of our eyes. So from this one we can clearly write that sin 2x. So I'll copy this one, and all the steps I can write sin 2x eventually. So sin 2x would be equal to, so I'll take this one and replace these places by tan x. So this can be written as 2 times tan x, and here I can write tan x squared, right? So this is the final relationship that we got here, right? Now we have already computed this factor, that is sine 2x as negative 3 over 4, right? So I'll be taking this and I'll proceed here further. So from this one we can clearly write that sine 2x, if I write it in terms of tan x, which I have got it here, I'll replace it over here. Now for simplicity, I'll consider tan x as t. So I'll say, let me just consider, this is my assumption, that tan x as t. So this is my assumption actually, assume, right? So this is, I'm just assuming it, assumption, or I can say let t be tan x. Now with regard to this t, I'll be solving this particular equation after making appropriate substitution. So this will be 2 times t and this would be simply t square. Now from this part, onward, I'll convert this equation into, I'll just, this is already the quadratic is given, I'll simplify this. So this would be 3t square, then plus 4 2 is 8, 8 times t, and this would be plus 3. This is equal to 0. Now on solving this, definitely two roots would be there. So t belongs to this two solution, that is negative 4 plus minus, representing both the roots here, square root of 7 over 3. Now if you observe here, which value should be considered here? So one value is with this negative and the other value is present with the positive right here. So these are the two different values we are having, correct? Now if you observe here in the problem, which value of t I should consider? Okay, just think about it, that which value of t I should consider. So if I write here, let's say t is equal to this, I'm accepting this value, but I'm saying that I'm rejecting this particular part. So what gives me that authority to do that, right? So if you observe here, it's already mentioned in the problem statement that x belongs to this 0 to pi radian, right? So because this is the reason that is already mentioned in the problem statement, so because of this fact I can say that for t, this is the selected value, that is 4 plus square root of 7 over 3, right? So now I'll just surround this within the parenthesis. So this is the final value for my tan x. My tan x is this. Now if you observe, the problem statement demands the answer for this particular expression, that is whatever is given. I'll just write it here as it is and then compute the answer for this, right? So instead of tan x, I'll just substitute this tan x by my computed value, right? So that will be this particular value which we have computed here. Now on resolving this further, definitely we'll get our answer as 9, right? So this gets cancelled and 3 times 9 is 27. Okay, so answer for this problem is 9, right? So that's the idea.